No, both the sides.
On both the sides. No, this is global effect. That's post-lunch effect. All right, we have 40 minutes to us, and we're just 5 of us. So I think a lot of people have been referring to planning, rather demand forecasting. And there's been a lot of comment on how do we transform procurement, logistics, but all in silos. Everything has been in silos. One of the fundamental aspects of planning is today we need to get a complete picture of the value chain. You cannot plan for the parts alone. And parts, I mean different parts of everything. In fact, I was speaking to a friend in the morning, and procurement head, I don't know, he's here or no, he's not here. And he was saying that the planning people in our department know nothing. No plans are correct. And then he also says that suppliers also don't know anything. They don't know what is to be actually stocked. So you have to, keep a lot of inventory. So I was very amused with this particular, this thing that if we know this, why can't we fix this? And then I asked him a question, how often you order? He says, as and when it is required, we keep ordering. And I realized that there is no concept of planning time fence. We are ordering and ordering and ordering, and we are creating nervousness and fighting in the department. I think this is critical. This is where planning has to differ. According to me, there are 3 different aspects of planning that we need to look at here. One, about not just the models, but the complete methodology that we follow. That's fundamental. The 3 pillars of supply chain planning, which I would critically say is this. Models, whether it's AI or whether it's a simple time series, and their performance. That's first fundamental plan. The second is defining the planning structure based on your lead times and planning time frames. It's a very standard O'Reilly MRP 9060 story, but it holds true. The only story has changed is that lead times have actually dramatically reduced. Nothing else has changed. And I think when you were talking about this in the earlier logistic one, I didn't want to intervene this because it's the purview of this panel to deal with this. But I think lead time, when you were talking about, Mr. Sarma did say that it takes a lot of time to reach the customer in the last mile. And I think that's a story. But that because we don't really plan for this, we don't really plan capabilities for this, infrastructure for this. We have just let it go. Second thing is that what is this planning time frames? It's cumulative lead time. It's a very simple thing. Even if you have a long lead time, you have to use that. In the frozen period, someone rightly said, in the frozen period, we don't really adhere to it. In fact, I know a company, it's not an auto company, where they had planning. So they called it SNOP, and then they called it dynamic SNOP. Dynamic SNOP was that even in the frozen period, if there's a demand, service it at whatever be the cost to serve. So this could be a fundamental challenge that we face in the planning arena. I thought the group has already been given some directions, but I thought I'll open it up also. We have both the world, one which was structured and another is unstructured. And look at in a very segmented way first as to the very importance of forecasting. Very importance of forecasting, one. Where does forecast sit in the supply chain planning? And what is the difference between a forecast and demand plan, and how do you create this demand plan? This is very first fundamental question that we really need to sort out. while moving into next generation. I think we have a lot of fad, AI. I'm not against AI, that's a but imperative. That's the way to go forward. But it cannot jump the gun. It cannot jump the gun. This is something that we really need to understand. And what it can do to help us design supply chain better, and in this case, supply chain planning better, is important. So let's first look at this. What is forecasting? Where does it sit in supply chain? And how it is different from demand planning? Ashok will go ahead with you.
Firstly, thank you very much, sir. And a very good afternoon. The most difficult question and the most fundamental question which is in front of me. The first thing is in terms of the demand forecast and the overall forecast, the demand plan and the forecast. The forecasting is central to any business because when you are making the business, it lies there in the business. Because it is central to the business and based on which you are making all your financial plans, all your resource plan, and all your capital plan, and all other plans are getting directed by it. So that is where it resides. In various organizations, it might reside with central planning, it might reside with marketing, it might reside with supply chain. Hardly matters. The thing which has to be done remains the same. This is considered to be the unconstrained demand, and that definitely is not the demand plan. The demand plan is shaped by our capabilities to serve the demand. And our capability means across the supply chain, and that is where we have to focus. Right now, if we have to look at the forecasting and then the demand plan is a response to forecast, then it is also shaped from both the sides. It sits in the middle. We do have the forecast on the left side, in the middle is the demand plan, onto the right side is my supply plan. Because unless I'm getting all the responses, I'm mapping all the responses to the demand plan, supply plan is a fundamental response to the demand plan, and that is where the demand plan remains. It is shaped by the scheduling abilities and the agility across the system and how much capability to execute. Because what happens is usually at some point in time after we are frozen, we become too stern to move needle even by a single degree, wherein our execution capabilities differ with the external environments. On to the second thing, it is very simple. If my constrained demand is equal to my execution plan, there will be no chaos into the system. The problem lies in the organization that who is taking responsibility for what. For forecast, they would say that it is a forecast because the name suggests that it is a forecast. It cannot be 100%, otherwise it would be firm. On to the other side, the execution, there would be some lapses, some delays, some or the other the factors which would affect. So eventually the demand planners actually keep there, they end up scratching their head that which way to look. You want them to have the enormous flexibility. So my 2 cents onto this is that this has to be done as an integrated way, end to end. Otherwise it will not yield you any. And the second is to plan better is to plan more. If you are too firm that I'll have the 15 days firm and firm period when I'm not going to change the plan, then be ready to forego the demand of the opportunities which are there in front of you many a times, not always. Because eventually it is going to take agility onto the overall supply chain. Usually what happens is that you are running all the planning and the scheduling cycles, say once in a week or once in 15 days, wherein all your suppliers are planning for 1 month. And that too on 1st or 5th. This is a typical automotive timelines. So on the 5th, you are freezing for the current month. And then your supplier already has frozen his all the ordering and then the resource planning on the 1st of it. So 5 days is gone, and by the time he communicates. The second is the agility. The biggest dimension which we usually miss is the communication. The communication also takes time. It is a physical process. Not that we have planned it and it is down the line, it is percolated and everyone has understood it. So this is where I stop.
So, as rightly said by my friend, Now, extending this part now, when we look at the supply chain planning from the perspective of multi-fuel and transition to e-mobility. So invariably, it will have its own challenges. One of the fundamental challenge which comes over here is, first of all, end-to-end managing the integrated supply chain. It requires a accurate demand planning. Now, what happens here, traditionally, if you look at from the perspective of the legacy vehicles or the IC vehicles, okay, the lead time for the component manufacturing typically varies between 2 weeks to 8 weeks, okay? And in the supply lead time, then if you look at the order fulfillment also, based on your manufacturing capabilities, you can, manufacturing the goods. Now, what happens when we have the EV vehicles coming in? First of all, we need to understand, based on the forecast, if you are really going to plan, that's really not adequate. One of the reasons for this is that specific to electric vehicles, certain components are going to have the lead time which are crazy. In some cases, those are 40. Now here what happens, you need to migrate from the existing forecasting to a demand responsiveness from the perspective of the OEM. And how you are going to do, you need to have a dynamic demand responsiveness wherein you keep on monitoring your demand, and based on your demand, your schedule in the back end should vary, and based on the schedules, then you need to plan for the back end integration. Now, when it comes to the back end integration, in terms of like demand measuring or a demand assessment from the market, obviously, when it comes to the different powertrains which are considered for the different vehicles, so hybrid will have its own powertrain, EV will have its own powertrain, IC will have its own powertrain. Okay. Now, when the business guys are going to assess the demand, they need to have a real-time assessment of what are all the digital inquiries they are getting in, what are all the digital bookings they are getting in, what are all drop-in customers they are getting, what are all the assessment and the festive season which are coming up, okay? So this needs to be done real time so that we serve the customer in a better way. When it comes to the manufacturing aspect of this, as you rightly said, since there is a different lead time for the different set of engines or powertrains, now obviously it's going to be very difficult for any of the manufacturers to manufacture or put a setup to manufacture all these three kind of or four kind of fuel on a one assembly line. Obviously, each powertrain will have their own set of lead times. There is a set of safety stocks as well as the transit stocks. Considering this, there would be an impact on the investment as well as in terms of the resource planning for the manufacturing as well as for your storages. So I think these are the few critical aspects when we consider in terms of the integrated supply planning for migration from the current existing vehicles to a futuristic e-vehicles. So we are going to have a lot of challenges in terms of managing the supply chain. And one of the solution is that you need to have the real-time assessment of the lead times. What are all the geopolitical situations are there? What are all the various current events happening in various countries? And based on that, there are going to be an impact on your supply chain. Typically what happens, like for example, if we consider the electronic supply chain, why there is a lead time which is more crazy? One of the reason for this crazy lead time is the fragmented supply chain the e-components are having. So you will see the wafers are being manufactured somewhere there in Europe or America. Then those wafers are being sent across to somewhere in Taiwan, China, or countries like this, or Vietnam or Malaysia, to further assemble these, pack these, and then those are being shipped to the various distribution centers. So when you consider the entire complexity involved in the electronic supply chain, that's if you look at from the short-term perspective, I don't think it is going to go away. It is going to stay there, and we need to find out a way how we can manage with those kind of complexities, how we can have a strategic alignment with the critical suppliers so that we, we end up in having a good delivery rates. And many times, and I observed since I work on to the new developments, my observation and experience is that whenever we select a supplier for any of the electronics component, typically it is said that your project delivery would be driven by the supplier who is you selecting. If in case you are not getting engaged with the supplier strategically for the electronics industry, then obviously it's going to create a gaps in your entire planning process. So you need to have a early engagement, early discussion, technical discussions with your supplier to make sure that those your pilot builds, your various builds are being supported by the supplier with a due course of time, with the cost, quality, and delivery, so that we end up in having the right delivery, right time, and then at the time of SOP, we have the adequate stocks which are already in place, so that we don't have the disruptions at the time of SOP. So I think that's from my side.
In continuation of the discussion, actually, I would like to put forward all of you. The law of demand or law of forecast says that every forecast can go wrong. So that is about the truth of forecast, that we all are said that forecasts are varying. Now, it is not true that every forecast is wrong. Actually, forecast goes in a variation of a certain performance, like goes. So, every process has got a tolerance, forecast also has got a tolerance. That entire system has to understand, and that is the tolerance of entire system, right from the market economic scenario to the entire supply chain member, it is a tolerance. So, that tolerance in automobile industry where I work, my name is Sanghai, I am working with Endurance Group last 25 years and 40 years in automobile supply chain. Generally, demand goes higher by 20% maximum. Till today, actual demand has not gone more by 20%. Demand fails by 30 to 40% also. Sometimes demand goes up to 60%. So what variation we are talking about to integrate and perform smoothly without affecting anybody's downline, fixed downline. So that is important. So we have to integrate the fluctuation of minus 40% and plus 20%. So that is the tolerance industry has to operate. Then coming to the manufacturing industry, what happens? If you have got a multiple supplier, say you got a requirement of say 1 lakh vehicle you are manufacturing. If you got a 2 sources, you have to keep a flexibility of higher size 20%. So each source should have 60% capacity. So you have got a 20% excess capacity, 10% you can accommodate, that can support for your new development. So that is one part. But if you got a 40% failure there you need a support of cost. Somebody has to own that, because below 20% because everybody's bottom line cannot be supported. So volume-based costing also has to come into the picture, but that is a challenge. Nobody want to change the price. Nobody want to pay the premium freight, that is a challenge. Nobody want to pay the extra cost, that is the entire industry supply chain has got a challenge, and the weakest member get more affected. So there are the tiers. So tier 1, tier 2, and tier 3 and tier 4, up to that auto industry is working right now, and every tier has got its own competency, benefit and the gaps. So those all gaps we are talking about the aligning. Integration means we are aligning the everybody as per their strength and pulling them forward. Actually what happens when it comes to the forecast or planning? Actually if anybody doesn't plan in time, planning also has got a prerequisite. So planning has to have got a base and assumption. So those assumptions how you clear across the supply chain. My experience is that if assumption of every member is correct, then you got a gap of assumption is not there. So assumption gaps, when it is reduced, you perform within the acceptable tolerance. So that but if any misplanning happens because of the information or communication, like communication doesn't happen timely, communication doesn't happen truly, because there is no trust in the communication, those challenges are there. If those gaps are there, that makes rush action to all other members. If one member does the misplanning, or within the company other department makes some misplanning, entire the focus comes on the supply chain, how that gap you can cover. And the strongest member has to take care, but at the same time, weakest member also has to work on that gap, and rush actions are created. Now, how we operate to this rush action with the technology? That is, there are benchmarks, and people are operating on these benchmarks. If Tesla as a new car company comes in, and they produce a car within the 30 seconds or 40 seconds, and they talk about reduce by the throughput time further, and they want a car per 10 seconds, and that is the electric vehicle platform they are coming up. There is somebody working as a benchmark on this. That is also auto industry example. But what Tesla has done, they have driven the innovation in that. They have gone for the giga casting, multiple part they have reduced into the one part. They have reduced multiple robo into the one robo. So can entire supply chain do these innovations? So how that technology can pass on to the supply chain? So that we have to work like a Toyota. So we have to train our entire supply chain members, send our engineers to the lower tiers and adopt them responsible, make them to avoid my planning, forecasting and demand and supply gaps. So working along with the supplier. So engagement with supplier, engagement with the market and engagement with the customer is a key process where we can have a good demand fluctuation within control and then everybody can have minimum losses on that. So how we can use the technology. So all of us are very comfortable with using Excel sheet. Although we put SAP, MRP, we have discussed up to what extent we use it and how frequently we use it. So how entire tier can have one system, like if SAP is working in a OEM, how it can work to the last member of the supply chain so that everybody understand what you are saying and there's no non-valued activity across the chain. Because everybody, if we're talking about the planning and integration and value addition and value chain, why everybody should consume the time in planning? If there is a combined plan coming from the OEM, once OEM distributes that plan, that everybody's plan should automatically work out. And that everybody should accept and only should give confirmation. But everybody makes his own planning, then everybody makes his own error, then there are everybody's gaps, and then misplanning comes to a rush action to that. So we have to work within the tolerance, reduce our tolerances, works on the gap. Every industry, these are the different techniques, but common problems and challenges are same. Information flow, response. Because how we respond to any communication comes. So there is a major problem comes. If response received late, again there is a challenge that you doesn't come to know whether to be or not to be and risk position comes. So my input is that first alignment of thinking and strategy at the pre-request of the planning has to happen. Means entire supply chain member should agree with the variation. What is the timeline and what we commit to, what happens. There should be a scenario planning clearly available. If we come to 60 by 40% less to 60%, or we go to the 20% level, what are the pros and cons and how system should work. So that should be made very clear to the entire supply chain members, and the higher member should work with lower member without looking at the cost and without looking at the gaps, how we can strengthen the entire supply chain. It's only strength respects strength, and we have to go on creating that strength. Weakest link we have to correct for the information flow and the entire alignment of the supply chain as the integrity is required. That's what I want to say.
Pandya?
Can I just... So, most of the points have been covered by the previous panels also, and even my panel members have covered, but just I want to add few things over here from the basic subject point of view, which was about the e-mobility transition part. So, imagine sitting in the boardroom of a powertrain component company 5 years before, and most of the predictions that they were seeing in the market is that EV adaptation is going to be in 30%, 40%, 50%. And here we are still struggling to, I'm talking about a four-wheeler point of view, definitely two-wheeler has gone ahead much faster and things are much better over there. But if you still look at Indian scenario, the EV adaptation has been as low as 2 to 3%. And here we were, I remember working with all these OEs and we were pushing them really hard, the suppliers, to invest in two quite expensive technologies, which were must to get into the EV adaptation part. So things are so unpredictable, and most of things, such kind of things get really hyped about it. And that's where I was really wondering, I remember back then in just before the COVID time, Suzuki had come up with this very clear direction that we are not going to go the EV fast route. We will first focus on the other powertrains also, like CNG. And they were so right about it. And they pushed a lot of suppliers to put into the investment into that area also. So that kind of agility is a must in supply chain. What I feel is demand planning, even if you take it as a longer horizon, because most of this kind of adaptation of new powertrains requires tremendous amounts of investments and also a long lead time. China has leapfrogged this far ahead of us, and we can't be even competing with them any time in near future, I would say. So in that case, the most important part still remains is the agility part. How we can adapt to this changing dynamic scenario of the market. Can we adapt to certain mix in CNG, certain mix in LPG, EV also coming in, and the most important part, hybrid. Perhaps even as government of India also was pushing too hard on the EV part and missed out on a very important part, which was a hybrid thing, where most of the Japanese OEs were doing quite a good job of having that technology in place, because EV is not just dependent on the manufacturing readiness point of view. It was also dependent on the infrastructure for the charging infrastructure coming in. And the complete ecosystem, the way China has brought in, that's the reason their adaptation is as high as 38%, 40%. Whereas India still, we are struggling into 2% digit. So that's where the supply chain agility is of prime importance, that irrespective of which way the market would really go, we need to be ready for all this kind of powertrain mix and be able to really integrate into this. That's where the integrated business planning really comes into picture, in my opinion. And even when China is the only exception in EV, otherwise even US market is struggling in EV adaptation because it's easier said than done. So all this hype that was created 5 years ago, again, I'm sure if we again sit down, if we look at the big fours would be still predicting, oh, the EV adaptation is going to be still very fast. But irrespective of what the prediction is, it's always going to be the supply chain agility, which will help us to adapt to any situation which has been thrown our way. No predictions or no demand is going to be accurately planned, in my opinion.
All right. I think we got a very strong dose of the challenges that we have in supply chain. The question stayed on the very first level. And the question which essentially meant that what is the role of forecasting? I think it is very simply to understand that it's a base plan, it's not the demand plan. That's the first difference that we need to make. It is necessary because we see the trend, and even if you see the trend in terms of substitution, we see the trend, like into EV. That means it can be used, if you have the right tools, algorithmized in the process, you can understand this particular thing very well. Second, how do you see that you capture the true demand in the market? There are many things that you need to be made to stock, so you cannot say that, oh, everything has to be agile. Agility can be from made to stock also. So how do you really look at this? And this is where the demand sensing comes in a big way. This is where you have your marketing factors, you have your external factors, you have your logistics factors, you have weather factors, you have disruption as an index, emergency as an index. Can we use the modern tools to predict and put a value to the demand sense added to the forecasted demand and come with a demand plan which is much higher? In fact, one of the most ridiculous thing that we do is that we look at forecast accuracy as a measure of performance when we don't use the forecast. And hence it's the demand plan accuracy that should be the accuracy methods. And I think this is fundamentally, I think it's missing as a piece. Missing as an understanding, missing as a piece. And when you model your forecasting software also on this basic belief, then you miss the woods. So according to me, this is a fundamental step that and this should be unconstrained. It should be then constrained with all the sense. This thing, and obviously one has to really look at what we can look at in terms of adopting to new norms. What is the segments that are emerging? How do you look at the segments? What is the decline in few segments? What is the rise in few segments? That can easily be used. I think numbers, this data in its raw sense has a lot of insights. Raw sense has a lot of insight. We are complicating insight with modern technology but not understand. This is what I said in the morning, that if your AI is traditional, it's data science, it's useful. You move to generative AI to do predictive, and you prescribe with use of agents, as you saw in some presentation. If you don't understand that we need to use them in a very different way to get different, what is it like in terms of analytics? You are having diagnostic, predictive and prescriptive. This is what it's all about. This is what you need. And understanding that from a simple framework is very important. And using AI for edge forecasting, I call it as edge forecasting. In smaller elements, when you are struggling with your data legacy, would be very useful to do demand sensing, reverse logistics forecasting, and everything can be forecasted there. And these are in smaller segment where you don't really need the legacy of data. So anyone who says data needs to understand that the smaller segments, which are even quarter basis, can be used to this. So this is a fundament. It has to reside somewhere in the process. And one of the fundamental elements is that how do we use technology to further strengthen and make it a part of the value chain? Before that, I just have one say. Everything is master production scheduling. Everything. You give a new name in your solution, that's great. But your demand plan decides this, and this decides everything that you do based on your planning time frames and lead times. That's the fundamental, simplest truth about demand planning and hence supply planning. We miss this. So I think this is one thing. Let me go to the not so obvious questions that we often ask in supply chain planning, which essentially someone made in the earlier this thing, is that technology is a must, AI is a must, but how do you adopt them for insights and decision making? Unless you have a very strong integrated business planning. Why we fail is because your SNOP is broken, your IBP is broken, and hence your technology acquisition is broken. I see it the other way around, and this is fundamentally true for organizations which are in SIFT. So what should we do in terms of governing and managing the supply chain planning? The first fundamental question that we need to really tackle. So we'll go with you. Just 1 minute each.
Yeah, I'll try and make it as short as possible. So honestly, you really pointed out this very important thing that everybody is considering this AI as a magic wand which will solve all problems, but unless you don't have that integrated business plan process in place. And in that also, my specific anecdotal evidences that I came across during my experience has been that we stop asking questions beyond a level. We only scratch the surface and understand, okay, this component is coming from XYZ supplier, and I have a visibility till tier 1, tier 2, tier 3, but not beyond that. Like rare earth magnets becoming such a big bottleneck had come up as such a big surprise for the entire EV industry. Now, none of this was known to even most of the manufacturers that this is such an integral part of it. So that's where, as you rightly pointed out, technology adaptation is a must, but at the same time, your integrated business plan has to be very, very deep in terms of understanding the complete value chain, and that value chain cannot be stopped at one level that, okay, I'm only responsible for this supplier, so I need not to know how is he managing his kitchen. I need to know exactly what's he's putting in his every kitchen that he's presenting me in the final, in terms of final dish, but I need to know exactly what's going where and what's coming from which end of the world. Because with such an integrated supply chain, we are so vulnerable to any disruption coming from any corner of the world. And world is becoming more and more uncertain and unpredictable by passing day. So it becomes even more interesting. And one of the guy also mentioned this earlier in one of the panel, the discipline plan is very important, right? The discipline, again, is the same point that I'm also trying to drive, is that don't stop asking questions beyond one level. Understand the complete value chain right from the level of where the minerals are coming from, and don't stop at just where my component is coming from. It's just beyond component to raw material to the process to where the end mineral is coming from. So that's what would help. Thanks.
We are coming to the issue of diagnostic approach Singh has brought to the table. Then we are talking about the analytical thinking. What is mean by analytical thinking? So who is doing the analysis and who is doing the diagnosis? So there are the professionals in the organization who are expert in the area. They are doing the diagnostic and they are doing the analytical approach. As per their experience, they are coming with the solution. Now that may not be the complete knowledge they are having of the system, but they are trying their best. So here the role of technology comes in so that we can use alternate options which are not known, but we can use the expertise of execution those options to your knowledge of your system. Suppose we are talking about the EV components. There are active components and passive components. So there are non-cancelable orders and cancelable orders. There is some situation come because of some decision in US, some company in China gets closed immediately and they cannot dispatch. Now I have to use here the technology where those parts are available alternatively, or which parts I can get with what way. So there I can use the AI. I can ask you what is the alternate route for this, or has anybody used. So this is the use of technology. Then if that route also is closed, I can ask for the alternate route. So how to use AI, that skills are required. How to use that technology, that is required. So diagnostic approach and analytical thinking, person has to do, but person can take an input from the technology. And technology can be used for it's deciding alternate part itself. If one active component can be definitely replaced by another active component somebody is doing. Suppose we are talking about a battery management system of a battery pack. So in that there are going to be some MOSFET, some resistance, some microchip components and all. So if one particular company has closed and their stock is not available with one particular dealer where we have placed the order as per the right lead time. I have given 6 months before forecast. I am buying continuously from them, but he has got his unforeseen situation. The company in the back is not supplying because of their unforeseen situation. So here we have to use the technology who is using what alternate components, where those components are available, and then entire supply chain has to respond very fastly on that. This component has been used alternatively for this particular battery management system by others, and this works well. So you have to reduce the time of testing, validation. There also you have to use again a technology, and then those reduce the time for responding to those changing situations. Like a surgeon does an operation or a soldier operate on a border, he has to respond on a change management. Here also the entire organization and supply chain professional has to operate that change management by taking the technological input and reduce those timings and meet the demand, whatever we can demand. So,
yeah, Pramod.
Hello. So in terms of use of technology for the supply chain, so I strongly believe that definitely there is a big role technology is going to play. One of the fundamental aspect over here is, let's take a simple case of, the demand variation for the different regions. Take a case of India. As you know, the demand is output based on certain inputs. Now, inputs are like government legislations, okay? Your fuel prices, availability of the, fuels, okay? Now, if we look at this as one of the case, in this case, like fundamentally you will say NCR, there is a big propagation of the CNG vehicle. One of the reason is the protection of the environment, which has gone through. And you will see a set of model which is existing over there, that a certain set of 20% vehicle will be going for CNG only, okay? Other way, if you look at any of the region like Mumbai or so, you will see that the diesel prices are pretty high here in Maharashtra as well. So you will see the customer inclination towards moving towards the non-diesel vehicles. On the other side, if you look at propagation of the EV vehicles that way. So there are different categories: 2-wheelers, 3-wheelers, 4-wheelers, and then commercial vehicles. Fundamentally, if you take into the 4 category, I strongly believe that, if you look at the functionality of the EV, so 2-wheeler and 3-wheeler, definitely there is a high chances and high probability that this might get converted into EV. Considering the technology challenges of the fundamental challenge on the EV is the range. So if you look at the application for the 2-wheelers and 3-wheeler, that's right now the technology is there wherein it complements the uses and the application of that specific vehicle. So definitely that can move on. Then for the car as well, if you look at the intercity transport, so obviously there is no reason that intercity transport cannot be done without EV. Consider your day-to-day commute. If you are traveling for a distance of 50 or 100 kilometers in a day, one side only. So if you look at the vehicles today, those are having ranges more than 500, 600 kilometers available, okay? So these are the few case studies or these situations and scenarios are there. Now imagine the situation that you key in these kind of situations and scenario into your AI agents and try to predict the demand from the demand sensing perspective. So definitely I believe that you can, if we use the technology, the demand prediction can be more accurate. It can be more better. And from the supply chain perspective, today we had a demo session from Kenexis also. And I was about to ask them one question. Like, for example, they are using their internal data, like organization data, to project like what are the shortages, what are the demands, and who is supplier failing, who is not having a capacity, all this kind of thing. Now imagine a case study or a hypothesis situation wherein you have a input coming into Kennexis, which is real time. Like there is some kind of sanction which is coming on to some of the country. Or there is a situation like a geopolitical tension resulting into some kind of long-term instability in a specific region. So there are indicators like this, like GDP. What are all the government initiatives and government priorities, like the way Indian government is now supporting a lot in terms of the semiconductor industry development. Various PLI schemes are being rolled out to promote the industry where we are lagging. So I think if these kind of inputs, external inputs outside the organizations, if those are being sensed by these kind of technology, I think we can have a very well, input for your, first of all, the demand sensing, and on the other part, the responsiveness of the supply chain as well.
All
Obviously, it's a long way to go, but I mean, that's what I think.
Thank you, Pramod. Ashok, last view.
The last view is that tools are definitely needed. Then the parameters are needed. Rather than the way we need to change is, right now we are actually in, after demand sensing, for demand consensus is the process. We debate onto the numbers, what has been the output. Rather than wasting time onto that, if during the time of the data setup, let us debate n number of times that what is the weightage to be given to each of the variables which are going inside it. So that further to it, it is a binding on to all. Because after we are going in for the demand consensus, people start disputing the levels which have been set for the variables. So it would be better that we debate there itself that yes, this is where 20%, 7%, 15%, you put it there.
All right. I think we have dealt with only one aspect of it, I think very focused. One thing that is really important taking off from all of you is that when you look at governance of supply chain planning, it is very important, as Ashok rightly said, that few steps are followed. Sometimes theory provides a better practice approaches. And that is, you do a portfolio analysis of your product first. Once the portfolio dynamics are understood, you do a demand planning or demand forecasting, demand planning and demand review with marketing and sales so that everybody is on the same page. Then you move into supply review and you marry supply and demand review into one. Once you get this particular plan, you go to the financial reconciliation and then go to the integrated management reconciliation. I think this is where the frozen zone can define. If you are defining any frozen zone arbitrarily, it has no meaning. Everybody buys the same schedules and part. In the morning, something came out that what happens, we don't change the frozen zone. No, there is emergencies, deviations that can be taken into account to create a frozen zone inventory based on your past experiences and also current experiences. So you can create a business continuity of a week by having this particular process of emergency stock, what you call it as safety stock. I think everything can be reimagined, whether it can be reimagined in a software or it can be reimagined in process, it is important. But anyway, we got good views from all four of you. Thank you very much for the insight. We take one question. If there is anyone. Yes, please go ahead.
Is very low, and they obviously attributed reasons and shortcomings to supply chain planning probably. But there are some factors which are external. For example, the government had mandated all IC two-wheeler manufacturers that after 1st April 2018 or 19, I forget the year, no vehicle without Euro 6, Bharat 6 will be cleared by the RTO. So IC manufacturers, in about a very short period of time, they spend about 4 to 5,000 crores to upgrade their plants to Euro 6. Now, when the EV, immediately after that, a couple of years, EV manufacturing started, two-wheelers, and the government planned a lot of freebies, a lot of ashirwads to promote the EV segment. But the IC manufacturers put pressure on the government, saying that we have invested 4 to 5,000 crores per plant, and this, the break-even will come only about 8 to 10 years later. And if you guys give so much of ashirwad to EV industry, we will, you know. So the government is deliberately, that is my personal assumption, trying to delay the, because in Maharashtra, for example, if you have to set up 5,000 charging stations, the vendors are ready, everything is in place. It is a matter of 3 months, but they are not doing it. And because of that, the EV percentage, as Tapan sir said, कि बातें हो रही है 40%, 30%, लेकिन हो कितना रहा है 4%, 5%. तो मेरा ये मानना है कि other than supply chain planning, the external factors should also be taken into account.
Definitely. This has happened yesterday, this will happen tomorrow as well.
I have one point, extending to what he said. You have to study different markets for this kind of integrated supply chain planning. What is happening around our environment? Look at different geographies, how they have planned this power train, like for example, multi-fuel or e-mobility. What are the kind of power trains the different geographies are evolving? That also need to be studied. So you can see that Japanese consciously they never propagated e-mobility. Even today, the number one automotive company, Toyota, does not believe in e-mobility, even though it is sustainable, it is environmental friendly. And similarly, all the other Honda or even Suzuki. So there is some reasoning behind this, because they have some limitations in the supply chain. The EV supply chain requires the battery technology, the raw materials, and many other interconnected materials which are not easily available. So supply chain planning for the e-mobility is not so simple. So they are not very consciously gone into hybrid mode. So the supply chain planning has been influenced by their capability to have the secured supply chain of raw materials and key ingredients that go into that. So I think in this planning, basic assumption should be that what is your strength as a country to sustain this powertrain solutions. You have to be conscious of the fact that you may have a policy, you may have a regulation from the government, but as he said in the rare earth magnets, if you don't have rare earth magnet, if you put all in e-mobility policies, it never will succeed. So basic strength is having your raw material security and supply chain backup to succeed. So supply chain planning will be bottom-up approach, in my opinion.
Absolutely, sir. And just to add one more anecdotal example to what he rightly said, even Brazil adopted the biofuel so early in the time, where most of the world was moving towards EV and different powertrain technologies. They adopted. So very valid point that you need to be sure of what your ground realities are, what your strengths are, and whatever opportunities are coming your way, whether your strengths are in line with us. Doing that SWOT analysis, the most important part is to align your strengths with the opportunities, not trying to follow every opportunity coming your way. So very well point. Thank you.
In fact, in the IBP, this is a long-term plan. You have to break your plan into operations, strategic and long-term. And this is very important to bring the country. Anyway, good discussion. Thank you, all of you who have contributed to this.